So hi everyone, this is a continuation of our discussion for your CK and LDH. So for today, we will be discussing the laboratory inserts of your CK and LDH. So these are the procedure that we usually perform in the laboratory. So I'll give you a mga drawings and somehow the processes of each of the following tests. So let's start with your CK. Ay, saan yung ito? For your CK, so, zoom ko lang kay medyo may hintayin ko lang kasi nga medyo nag-delay siya sa screen share. So your CKMB not activated, it is actually a homozyme M test using a immunoinhibition method. Kanina, di ba, we discussed about your immunoinhibition. This is a immunoinhibition test. So, it is an enzymatic CK determination accompanied by an immunoinhibition method. An antibody is incorporated into the reagent which will bind specifically to the M subunit inhibiting the enzymatic activity of the subunit. Thus, only remaining activity of the B subunit is measured. Due to the negligible concentrations of CKBB in the circulation, the remaining activity multiplied by the factor of 2 represents the activity of the CKMB isoenzyme. So anong ibig sabihin nito? Simple lang. We have an IgM, we have an immunoglobulin that will inhibit your M subunit. Remember that your CK has 2 subunit. We have your CKMM, CKMB, CKBB. Pero sa test na to, ini-inhibit natin ang M. So ano ang na-detect is your CKBB. But remember, your CKBB is negligible. Konti-konti lang siya sa blood natin. So technically, ano pa rin ang na-detect is your CKMB. You multiply that by the factor of 2. So ito yung enzymatic principle of your CKMB NAC activated test using your immunoinhibition. So ito yung mga principles na discuss natin. We have your creatine phosphate by the action of your CK. Anong nangyayari? You add phosphate to your ADP, nagiging creatine plus ATP. Ang ATP, add ng glucose with the action of your hexokinase. From the name itself, hexokinase, it will transfer the phosphate group of your ATP towards the glucose, forming now your ADP plus D-glucose 6-phosphate. Your G6P plus your nicotinamide adenine dinucleotide phosphate by the action of C6PDH will lead to 6-phospho D-gluconolactone plus your reduced nicotinamide adenine dinucleotide plus your hydrogen ion. So sa kit ng CKMB NAC, meron tayong different reagents. Ito yung mga reagents na dapat nating tatandaan. Meron tayong, antayin ko lang, medyo nagde-delay siya sa ating screen share. Okay, meron tayong buffer, meron tayong enzyme. Ang buffer natin is around 6.7. Ang enzyme natin, kasi nga tinawag natin enzyme, kasi nga nandun yung mga enzyme na kailangan natin. Nandun yung hexokinase, nandun yung G6PDH, creatine phosphate, and other mga other substrate na kailangan natin. So basically, sa enzyme, nandun nakalagay lahat ng substrate at saka enzyme. Additional material but not specific, wala na yan. So let's proceed with the next page. Ito, dito. Nade-delay siya, check nyo lang, hantayin lang natin. So for your reagent preparation and stability, you reconstitute one vial of your enzyme. So kung sa kailangan natin ng isang vial ng enzyme, check. Tapos, with exactly 3 ml of the buffer. Tapos, i-add natin ang isang vial ng enzyme sa 3 ml ng buffer. Ito, check. Then, we swirl gently and incubate for 5 minutes. So, i-mix and ating i-incubate for 5 minutes at room temperature. Remember that ha? Only room temperature. So, 1 vial of your enzyme plus 3 ml of your buffer will yield into your working reagent. So, ito na yung magiging working reagent natin. Later on, we will see how this working reagent be used. So, for our specimen, ang mga specimen na ginagamit natin for CK is actually serum. Pwedeng serum, pwedeng heparinized plasma, or pwedeng EDTA plasma. Therefore, we could use a red top, we could use a green top, which is your heparinized plasma, and we could use your lavender, which is your EDTA top. For the assay, ang ginagamit natin na wavelength is either 334, 340, or 365 nanometer. So basically, depende yan kung anong gagamitin natin. For the benefit of an example, gagamitin natin ang 334 nanometer. Ang temperature could either be room temp around 25 to 30 and 37 degrees Celsius. For the measurement, it is against air. Wala tayong ilalagay sa gitna. So basically, may cuvette tayo, ilagay dyan, that's already against air. And check natin ha, increasing absorbance. So later, ang ibig sabihin ng increasing absorbance, if you check the absorbance of that solution, ano mangyayari is that may value. After several minutes, pag i-check mo, ang magiging value is increase. So the absorbance will be increased. For example, check mo ang absorbance ng sample nito is around 500, 0.500. After 1 minute, check mo ang absorbance, nagiging 0.600, meaning increasing absorbance. Kasi nga, may other test na decreasing absorbance. Ang LDH natin guys is decreasing absorbance. Ibig sabihin ng decreasing absorbance, for example, first test mo for the absorbance is 500. The next, after 1 minute, ang next value will be 400. Meaning, nagdi-decrease ang value. Hindi siya tumataas. Pero for CKMB and for this kit, ang ating absorbance is increasing. Tatandaan yan. Because this will give us an idea whether our test is actually correct. Kung increasing absorbance natin, that will be correct. Pag nakita natin sa ating result later on, increasing ang ating absorbance, that's gonna be correct. Pero if ang ating absorbance is decreasing, paliit ng paliit, then that's gonna be doubtful. That's gonna be incorrect. That's why it is important to determine whether this kit follows a increasing absorbance or decreasing absorbance. For this test, it is increasing absorbance. Again, meron tayong vial, 3 ml na buffer, nagiging working reagent natin. So how do we test? Excuse me. So we warm the reagent and the cuvettes to the desired temperature and must be kept constant for the duration of the test. So in terms of whether micro or semi-micro ang gagamitin natin, it's your choice. Pag marami tayong sample, we can proceed with a macro test. Pero pag kulang ang sample, if we have already few amount of sample, konti lang ating reagent, then we can proceed with semi-micro. Since ang ginamit natin is nag-prepare tayo ng working reagent, ang gagamitin natin is semi-micro. Bakit do? Kung macro ang gagamitin natin, pag macro method ang ating gagamitin guys, ito, pag macro test ang ating ginamit, actually, ang gagamitin na lang is you pipette directly into the reconstituted working reagent. Meaning, ang lahat na ginawa natin na working reagent, dadagdagan lang ng 100 UL na sample. Again, pag macro sampling ang ating ginagamit, yung ginawa nating working reagent, lahat ng ginawa ng working reagent, lalagyan lang ng 100 microliter ng sample. Pero for this example, ang gagamitin natin is semi-micro. Anong nangyayari, Doc, pag semi-micro? Pag semi-micro, anong nangyayari is that yung sample, 40 UL ng sample, ito serum, 40 UL niyan, plus your working reagent, kukuha ka ng 1,000 UL ng working reagent. Tapos, i-mix natin serum na 40 UL plus working reagent na 1,000. I-mix natin at saka i-incubate for 10 minutes. Ang gagamitin nating temperature is your room temperature. Specific natin is at 25 degrees Celsius. So, mix and incubate at room temp for 10 minutes. After that, after ng 10 minutes, ano nakalagay dito? Mix and incubate the desired temperature for 10 minutes. After 10 minutes, you read the absorbance A1, and exactly after 5 minutes, read the absorbance A2. Okay, na-incubate na natin ng 10 minutes. Ito na yon, 10 minutes. Kuha, ilalagay mo sa cuvette. Ito, di ba? This is our cuvette. Tapos, kanina sabi ko, ang ating wavelength for our spectrum na gagamitin natin is 334 nanometer. So, i-input mo lang yan sa machine, 334. Tapos, kukuha tayo ng ating in-incubate. Lahat ng solution na ginamit natin dito, ilalagay natin sa ating cuvette. Tapos, ano na sinabi? Read the absorbance A1. Meron ka lang ipipress sa machine. Press that. That's gonna be your A1, absorbance 1. Ang value na lumabas is 0.5061. This will be our first absorbance after 10 minutes of incubation. Then, exactly after 5 minutes, read the absorbance, which is your A2. So, after 5 minutes of reading your A1, you check now for another absorbance. That's gonna be your A2. And the value was 0.5052. 5052. Tama ba ang ating absorbance na decreasing? Check ko muna ha. Wait lang. I-confirm ko kung decreasing ba dapat. Increasing absorbance, mali. Okay, there's a correction. Increasing absorbance dapat. So again, this is why it is really important to check whether increasing or decreasing absorbance. Sige, baliktarin na lang natin to guys ha. This is your A2. Correction ha. This is your A2. This is your A1. Kasi nga, dapat increasing absorbance. Hindi ko na-check. I repeat again. Mix and incubate for 10 minutes. And after 10 minutes, ilalagay sa cuvette and i-detect ng ating spectro. I-check ang absorbance. For the first absorbance, after 10 minutes of incubation, the value was 5052. Tama ha? 5052. First value. A2. After 5 minutes, iti-check na naman ang another absorbance. Example, the absorbance detected was 0.5061. This is the second value. Correction ito guys ha. So for our first absorbance, the value was 5052. The second absorbance after 5 minutes was 0.05061. Increasing absorbance. Again, this is way for checking kung tama ang ating nakuha na absorbance. Next. Dito, at least tama ating nalagay. Sa example natin dito, tama ang na-check sa formula. Again, your A1 was 5052. Your A2 is 5061. Anong next procedure natin do? Ang next procedure is calculate the absorbance change per minute according to A2 minus A1. A2 minus A1. So, ito ating A2 ha. A2 minus A1. So, A2 minus A1. So, basically, to check for the absorbance of your solution, isa-subtract mo lang ang A2 minus A1. Since larger value ang ating A2 minus A1, 0.5061 minus 0.5052, the value is now 0.009. Ito na ang ating value, 0.009. Ito na yung change in absorbance per minute. Sinabtract natin ang A2 minus A1. Kaya nga, importante, increasing absorbance. That's why A2 should be greater than your A1. Kasi pag greater ang A1 sa A2, mali na ang ating computation, nagiging negative. So, for the calculation, ang ating na-calculate is 0.009. Is this already the final formula answer? No. Check natin. Diba ang ginamit natin is semi-micro? Semi-micro, dito tayo. Kuha tayo ng multiplier. Imo-multiply muna natin ang 0.009 sa kanyang multiplier. 8414. Bakit 8414, Doc? Kasi nga, remember, ang ating wavelength na pinili is 334. So, ito, 334. Sorry, tabunan. Ito, 334. Tapos, semi-micro. Since semi-micro, anong value dapat? It's your 8414. Ito, 8414. Wavelength of 334, semi-micro. Okay, gets? So, 0.009 multiplied by 8414, the value of our CKMB now is 7.57 microliter. So, this is now our value, 7.57. I-check natin, to check for the reference formula, check natin, anong ginamit natin na temperature? It's 25 degrees Celsius, 25 or room temp. Tapos, value natin, CKMB, is this normal or abnormal? This is normal kasi nga sa CKMB, which is number 2, tapos room temp, which is 25 degrees Celsius, greater than 10 UL there is a big likelihood of myocardial infarction. However, for our patient, the value was only 7.57, which is less than 10 UL, meaning our patient is having a normal of CKMB. Normal ang value na kanyang CKMB. So basically, this is only how you compute for the value of your CKMB. Let's proceed with our LDH. I know guys, medyo maliit ang ating insert. So, you can have a copy, you print it out, and then just follow my discussion, okay? For your LDH, it's a lactate dehydrogenase. It's a modified method based on the recommendation. So, the principle, again, paulit-ulit lang tayo. Pyruvate plus your nicotinamide, reduced nicotinamide, adenine dinucleotide, plus your hydrogen ion with the action of your LDH will result into lactate and an oxidized form of your, nicotinamide adenine dinucleotide. For your LDH kit, meron tayong ibang-ibang contents. Meron tayong reference number, meron tayong BUF, which is the buffer, meron tayong sub, which is your substrate, So, sa buffer, anong laman ng ating buffer? Meron siyang tris buffer, which is 7.35, pyruvate, and your sodium acid. For the substrate, ang laman ng substrate natin is your nicotinamide adenine reduced nicotinamide adenine dinucleotide and your sodium acid. For the reagent preparation, you can use procedure 1 or procedure 2. So dito guys, mimili lang tayo anong gagawin na procedure natin. Is either you go for procedure 1 with reagent start or you could do your procedure 2 with sample start. Sa procedure 1, simple lang. The reagents are ready for use. Kung anong reagent, yun na yun. Wala nang kailangang i-mix. Pero when we use the procedure 2 with is a sample start, now meron tayong kailangang i-mix. Gagawa tayo ng working reagent. So, meron tayong nakalagay na reference dito. Reference 1204, 12214, 12014. For that, pipili lang tayo kung anong reference na ating gagamitin. For this example, ang gagamitin natin is your 12024. For 12024, you pour the entire contents of your one bottle. Isang bottle ng substrate. Ito, this one. One bottle of your substrate into one bottle of your buffer. As simple as that. I-mix mo isang bottle ng substrate, isang bottle ng buffer, then that will be our working reagent. Yan na yung ating working reagent. Specimen, same with your CK. Pwede kang gumamit ng serum, heparinase, or your EDTA plasma. For the wavelength assay, pwede tayong gumamit ng 334, 340, or 365, depending kung anong ilalagay natin sa machine. For the temperature, for this example, we'll be using your room temp, which is your 25 degrees Celsius or your 30 degrees Celsius. For the measurement, it's still against air and decreasing absorbance. Anong ibig sabihin nga ng decreasing absorbance? Ulit. Pag decreasing absorbance, the first value, after that first value, the value will be lower. For example, the first absorbance was 0.500. Then the following absorbance will be lower, which is 0.400, depending on the anong nakalagay na value sa machine. But the clue here is it is a decreasing value. Next, meron na tayong working reagent. Now, let's proceed with this one. Ano ang procedure ang ating finalo? Finalo natin ang procedure number 2. Procedure number 2 ang ating ginamit, guys, ha? Kasi nga, sige, i-review natin ang procedure 1. Sa procedure 1, simple lang. Sample, which is 20 UL plus buffer. Mag-a-add ka na lang ng 1,000 UL ng buffer, depende kung anong room temp. Kung room temp ang ginamit natin, 20 UL na sample, 1,000 UL na buffer, tapos i-mix and incubate for 1 to 5 minutes. Then, you add substrate, 250 UL. Tapos, you mix and read the absorbance. Simple lang, procedure 1. Hindi ka na kasi gumawa ng working reagent. Pero sa procedure 2, since procedure 2 ang ating finalo, check nyo, pipette into cuvette, sample 20 UL. Ito yung sample natin, 20 UL. Kuha tayo ng 20 UL. Tapos, working reagent, 1,000 UL. 1,000 UL. Tapos, meron na tayo, 1,000 UL. I-mix and read the absorbance after 1 minute. So, in short, ang 20 UL at saka 1,000 UL, imimix sa cuvette. Tapos, ang cuvette ilalagay sa spectro para ma-read for absorbance. Ang ginamit natin na wavelength, tatandaan, is 365 for this case, ha? So, mix and read the absorbance after 1 minute. After 1 minute, you check the absorbance. For the first minute, ang lumabas is 0.400. Next is, at the same time, start the stopwatch. Read the absorbance again exactly after 1 minute, after 2 minutes, and after 3 minutes. Meaning, after reading your first absorbance after 1 minute, you check again another absorbance after 1 minute, after 2 minutes, and after 3 minutes. Meaning, we will have a total of 4 absorbance. After 1 minute, then after the first absorbance, you read the absorbance after 1 minute, after 2 minutes, and after 3 minutes. And the value of your second absorbance is 0.008. For the third absorbance, 0.0050. For the fourth absorbance, 0.0040. Remember, ano nga dapat ang absorbance nito? Increasing or decreasing? For lactate dehydrogenase, it is decreasing. Pababa. Kanya 400, 80, 50, 40. So in short, our absorbance is correct. Unlike in your CK, the absorbance should be increasing. So Doc, after that, ano na po ang gagawin natin? Then we will now compute for the value of your LDH. For the value of your LDH, ito lang yan guys, ito lang, simple lang. 'Di ba? First absorbance natin is 0.0400, second absorbance is 0.0080, your third absorbance 0.05, 0.005, your fourth absorbance is 0.004. Actually, the same pa rin like your CKMB. Sa CKMB, sinubtract natin yung second absorbance to your first absorbance. Here, ang gagawin natin, you subtract your first absorbance to your second absorbance kasi nga, we want to check for the change in absorbance per minute. So, per minute, ano ang changes ng kanyang absorbance? So, sa first absorbance and second absorbance, 0.0400 minus 0.0080, subtract mo ang dalawa, ang value is 0.0320. Next, since it is an absorbance change per minute, i-check mo na naman ang absorbance mo sa second value to the third value. Your 0.0080, you subtract by 0.0050, it is 0.0030. Next, your third absorbance, you subtract that to your fourth absorbance. 0.0050 minus 0.0040, it is 0.0010. Remember guys, this is the mean absorbance change per minute. Yung subtraction kanina, it is simply the absorbance change per minute. Pero we want to check for the mean absorbance change. How will we do for the mean absorbance change? We have to add these three values. You add the three values, you add 0.0320 plus 0.0030 plus 0.0010, it's gonna be 0.0360. Since this is mean, you divide by the value of 3. Now, our mean change absorbance per minute is 0.012. Is this the final answer, Doc? No. Again, we will multiply this by the factor. 0.0012 times 15,000. Doc, saan po natin kinuha ang 15,000? Balikan natin ang procedure number 2. Dito tayo kasi nga procedure number 2 tayo ha, hindi tayo procedure 1. Procedure 2 tayo. Sa procedure 2, anong ginamit natin na wavelength? It is 365. Sorry, tabunan. It is 365. Ito, 365. Since 365 ang ginamit natin, anong ginamit natin na temperature? It is room temp. So, 25 or 30 dito tayo. So, ang gagamitin nating factor will be your 15,000. Ito, 15,000 kasi wavelength, 365 and room temp. Room temp. So, in short, 15,000. So, our value, mean absorbance change per minute, 0.012 times 15,000. The value is 180 unit microliter. So, 100 microliter, which is, check natin sa reference value. Reference value sa room temp, specifically if 25 degrees Celsius, sa adult, it is 120 to 240. Kasi, for example, this patient is adult. Gamit natin is 25 degrees Celsius. Kumbaga, 25 degrees. Kailangan natin, we have to be very specific with temperature kasi nga ang value sa normal values will be different. At 25 degrees Celsius, ang normal value sa adult is around 120 to 240. Pag 30 degrees, it's around 160 to 320. For example, this temperature is around 25 degrees Celsius. The value will be normal value for adult will be 120 to 240 it's not microliter. What's this? I forgot how do you say it's UL. UL na lang guys, I forget microliter. It's not microliter, units per liter. I'll just check on that, okay? So our value was 180 UL. So this is, our patient is normal. So I guess that's how you compute for your CK and LDH. It's very important for you to know the computation because not all the laboratory will be using a using an automated machine. I was able to rotate, at my time, I was able to rotate at DRH at Tagum. And at that time, meron mga specific test, mga electrolytes na ginagamit namin is still your spectrophotometer. That's why it is important na at least you have an idea on how to compute, on how to perform. It's just very simple. You just have to follow the instruction. If you're not really sure for this one, please ask me some questions. So I guess that ends our discussion for our exam. Expect, of course, we will have a case series type of question, but this time I'll make sure na it's gonna be answerable. You will be able to answer it. Secondly, correlation with the different tests, most specifically your CK, LDH, AST, or TROP-I. Simple recall question, and also you have to study this laboratory inserts for your CK and LDH because this is laboratory part and this is really the thing that we perform in the laboratory, and this is, naalala ko pa nga at our time, ito talaga yung inaaral namin. We have to, dati in-memorize ko pa yung mga normal value, mga ganito. For my exam, of course, expect for some computation, pero basic computation lang kung ano yung tinuro ko. Of course, given na itong mga value na to, you just have to simply subtract and then multiply for the value. And I'll try my best kung kaya kong ilagay yung mga value dito para hindi niyo siya kailangan i-memorize. Or you can just simply print out na lang during our exam. At least you have a guide. You have a guide kung ano mga normal values, okay? You don't have to memorize. Okay, I'll get it. Mahirap. Ang daming yung i-memorize. So, for my exam, prepare for a calculator, pero lahat you print out or meron kayong copy sa side nyo while doing the exam kung saan nyo siya i-multiply, then i-divide kung paano nyo para you will be guided. Ang ibibigay ko lang is the absorbance. Pero make sure na you have a copy on your side para it's easier for you. You don't have to memorize everything. At our time, memorize namin yung lahat. Pero for your part, I know it's hard. You are not able to perform it. It's online. That's why I'm trying my best na to consider, guys. So for now, I want you to have a copy of the laboratory insert at your side during the exam, a calculator. Promise, I'll just make sure na it's very simple, okay? Kung ano lang yung diniscuss ko, paano i-compute, yun lang yun. For the normal values, you don't have to memorize kasi nakalagay din naman yan sa reference value sa table sa inyong laboratory insert. So for now, that's it. If you have any question, can PM me anytime. So thank you guys and God bless.